Okay, so now we're going to look at an example involving a parabola with a vertical axis of symmetry, all right? So here's an example. Graph the function identifies vertex, focus, directrix, and axis. Now, the only reason we can call it a function, knowing that it's a parabola, is because it opens up or down. Um, and the axis of symmetry is going to be vertical. It's going to be a vertical line. And I know that because x is being squared. And if you remember, this is the general form of a conic down here. The general form of a conic is just this general second degree equation. We have the term x squared. We have the quadratic x term. A is just equal to 1. But notice there is no quadratic y term. There is no term that has y squared. That's how I know that I can solve this equation for y. If you solve this equation for y, you'll be putting it in the form of a function of x. So you'll get y as a function of x, meaning it opens up or down. So because it is the y squared that's missing from this general form, I know that this is a parabola with a vertical axis of symmetry. Okay, so now what I want to do is I want to go ahead and find the vertex, the focus, the directrix, and the axis. But this form, which was that general form of a conic that I was just looking at, doesn't help me with that. What I want to do is I want to put it in this form. This form right here will allow me to identify H and K and also P. And if you saw the previous video, the video that had the formula where I derived the formula, you saw that if you know H and K, then you can identify the vertex. The vertex is HK. And you can also identify the focus because the focus is P units away from the vertex. So there's P. And you can also identify the directrix because the directrix is also a horizontal line. In this case, a horizontal line because the axis is vertical. And it's a horizontal line that has the equation y equals k minus p. So basically, if you know h, k, and p, you can identify the vertex, the focus, and the directrix of the parabola. And just by knowing h, you can identify the axis, because the axis of symmetry is, for a parabola where the axis is vertical, is just the line um, x equals h. So how are we going to find h, k, and p? Well, we have to put this parabola in the correct form. And like I said, it's in this conic form now. I want to put it in this parabola form. So what I'm going to do is, since x is the variable that has the square, since I have a quadratic term with x, I'm going to complete the square on x and move everything that doesn't involve x to the other side. So I'm going to complete the square on whatever variable has the quadratic term, and in this case that variable is going to be x. So I move everything to the other side. I'm going to subtract 12y and add 56. I'll get x squared plus 4x is equal to negative 12y plus 56. So I subtracted 12y and added 56 to both sides. Now the number that I need to add to these two terms to complete the square is going to be half of this term's coefficient squared. Half of 4 is 2, and 2 squared is once again 4. So the number that I have to add in on the left side is a plus 4, which will turn that into a perfect square trinomial. The number I'm adding in on the right side has to be the same number to keep this equation balanced. Plus 56. And I'm also adding in a 4 on the right side. All right, so now remember, my goal is to have it looking like this one here, the uh, form that gives me h, k, and p here. So what I want to do, this left-hand side is going to factor to give me x minus h squared. Perfect. All I need is for the right-hand side to have two factors. Actually, three factors. One of my factors is going to be 4. The other factor is going to be y minus some constant. That constant is going to be the y value of my vertex. And the last factor is p. So I'm going to factor the left-hand side the way I need it to be factored. The left-hand side, x squared plus 4x plus 4 factors into x plus 2 squared, while the right-hand side, well, the right-hand side is negative 12y plus 60. All right, so what do I need here? Well, on the left-hand side, I need it to be written as x minus something. So I need it on the left side to be written as x minus something. So I'm going to rewrite the left-hand side as x minus negative 2, because x plus 2 can always be written as x minus negative 2 squared. On the right-hand side, I'm going to factor out a negative 12. Why? Because you notice on the inside of the parenthesis, the coefficient of y is 1. The only way of achieving that here is to factor out negative 12. So negative 12 then is going to be multiplied by, when you divide this by negative 12, you get y, which was the point of factoring out the negative 12. And we divide 60 by negative 12, you get minus 5. So I'm almost there. I have pretty much everything I need to identify. Because this is written as x minus a number squared, I know that number is h. So h is the number negative 2. Over here, I also see that I have y minus a number, y minus 5. So k is equal to 5. I just need to figure out what p is. Well, to figure out what p is, I'm going to take the number in front of the parentheses here, and I'm going to factor a 4 out of that number. So I'm going to take a factor of 4 out of that number, and this is what you'll get. You'll get x minus negative 2 squared is equal to, when you take out a factor of 4, well, the other factor other than the factor of 4 in negative 12 would be a factor of negative 3, because negative 3 times 4 will give you negative 12. And here we have y minus 5. So now I have enough information to identify all the parts that I need. I know that h is equal to negative 2, because it's x minus h. I know k is equal to 5, because this is y minus k, and I know p is equal to negative 3. So I have my values of h, k, and p. So now I can do everything it asked me for. I'm going to do the graph last. Let's focus on the vertex, the focus, the directrix, and the axis. So first for the vertex, that's easy. The vertex, well, the vertex is the point hk. In this case, hk is negative 2 comma 5. The vertex, the next thing they asked for was the focus. Well, the focus has the x value h. So for the focus, the x value is h, which is negative 2, but the y value is k plus p, which is going to be negative 5, or sorry, which is going to be k, which is 5, plus negative 3. 5 plus negative 3 is positive 2. 5 plus negative 3, that's k plus p. So this is my focus. So I have my vertex and my focus. They also ask for the directrix. Well, the directrix is a line. It's the equation of a line. And in this case, it's the equation of y is equal to k minus p. So it's the equation y equals k, which is 5 minus p, which is minus negative 3. 5 minus negative 3 is equal to positive 8. So the directrix is the line y equals 8. So there I have the vertex, the focus, and the directrix. The only other thing left would be the axis of symmetry. Well, the axis of symmetry here is a line that goes through the vertex and the focus. And since the vertex and the focus both have the same x value, obviously that equation is going to be x equals h, the equation of a vertical line. And that vertical line is x equals h, which in this case, h is equal to negative 2. So there I have all the parts that he asked me for except for the graph. I have the vertex, I have the focus, I have the directrix, and I have the axis of symmetry. So let's go ahead and graph this. All right, so here I have my graph. Let's just plot these things down here. All right, so I have my vertex to be the point -2, comma 5. -2, 5. The vertex is actually a point on the parabola. So I'll graph that in blue. -2, -2, 5 is right here. So that point right there is the vertex of the parabola. That's actually one of the points on the parabola. The focus is the point -2, 2. The focus is the point -2, comma 2. So the focus is this point right here, -2, 2. Notice the focus is below the vertex. And the directrix is the line y equals uh, 8. So y equals 8 is the directrix. That's this line up here, which is not actually part of the parabola either. So we have 2, 4, 6, 8. This is the directrix, the line y equals 8, this horizontal line right here. And the axis of symmetry, well, the axis of symmetry is the line x equals -2, which is this vertical line right here. You remember the axis of symmetry from college algebra, I assume? Okay, so once I have all those things, the parabola is just a set of all points that are the same distance from this red point that they are from this green line. If that's going to be the case, this has to be a parabola opening down. The parabola always opens from its vertex in the direction of its focus. So this parabola would open downward like this. And the distinction of all the points on this parabola is that their distance from the the red point is the same as their distance from the green line. So there we have the graph. This is the directrix, the focus, the vertex, and all the other points on the parabola, assuming that the distance that any point is from the directrix is the same as that point's distance from the focus. And that is how you graph a parabola, identifying the vertex, focus, directrix, and axis.